Hey everyone, welcome you all to the YouTube channel of DCC NIT. Myself Mayur from third year CSC NIT curriculum, and today I am going to discuss the problem event Subarrays that came in Codeforces around 8.1 Division 2. The prerequisite of this problem is basically bit manipulation. So the question statement states that you will be given an integer array of size n, and your task is to find the number of subarrays of a whose XOR has an even number of devices. For example, 2, 3, 5, 6 have even number of devices, whereas 1 and 4 have odd number of devices. So the first thing that you should know beforehand is that like which are the numbers that have odd number of divisors and which have even. To answer this, we can actually say that like any square number, for example, 1, 4, 9, 16, 25, and so on, all these have odd number of devices and the remaining number have even number of devices. Let's take a look. Like here you can see that for 25, there are 3 devices, 1, 5, 25. For 16, there are 5 devices, 1, 2, 4, 8, 16. So you can say that for any square number, there will be odd number of devices, and for other numbers, let's say 12, there is even number of devices. For example, here 12 have 6 devices, 1, 2, 3, 4, 6, and 12. So this is actually kind of a fact. So our question basically boils down to the fact that we have to find the number of subarrays of A whose XOR is not a square number, or we can, in other words, we can say that like there will be n into n plus 1 by 2 number of subarrays in total. Then we can subtract all the subarrays that have a square number as its XOR. If this XOR value is some square number, then we'll subtract that. So we'll get all the subarrays that doesn't have its XOR value as a square number. So the brute force approach that comes to our mind is something like we can check for all the subarrays and calculate the XOR value. So basically, we'll check for all the n into n plus 1 by 2 subarrays and find the XOR value. If it is not a square number, then we'll add it to our result. And the time complexity will be n squared, which is of course not feasible. It will give clearly because the value of n can be up to 2 into 10 to the power 5. So to find some better approach, or let's say some linear or like O of n approach or O of n log n approach, something like that, based on this constant. Now, if you've done the problem something like sub is some equals k, that is also in lit code. This problem is very much similar to that. It will also use hashing, the concept of hashing, and like we'll check for all the indexes. Means we'll linearly go through all the indexes and use hashing to solve this problem. So this problem is very much similar to that. Now, let's take an example and try to solve this problem. So let's take the example 42153. So for this, we'll solve this problem. Now, our task is like means we'll think in this way. Let's say we're at some index. Let's say here we are at index 3. Then we'll ask ourselves how many subarrays are there starting from the very beginning and ending at 5. So now there are 4 subarrays. So one starts means one from here to here, another is from here to here, the third one is from here to here, and the fourth one is only 5. So there are 4 subarrays in total starting from the very beginning and ending at index 3. So out of all these 4 subarrays, we'll find out which are the subarrays that have XOR value as a square number, and we'll subtract that from our total result, which is n into n plus 1 by 2. There is a total number of subarrays. So in this way, we'll proceed. Now the question is like how, if even at some point, means if we are certain index, then how will you find like which are the subarrays that have the XOR value as a square number? So that is the next question. For this, we'll again take a look at something like this. Suppose we had some index, let's say this is an array, and we had certain index. And the current total XOR value starting from the very beginning to this point is x. The XOR value is x. Now I have to find out, let's say, how many subarrays are there, which starts anywhere from this beginning to means to up to this and ending at this point. How many subarrays are there whose XOR value is 4? This is square number, right? 4 is a square number. So I have to find out how many subarrays are there whose XOR value is 4. So let's say there's a subarray like this. The XOR value for this part is 4. So this is 4. Now, by XOR property, we know that if the whole XOR value is x and this part is 4, then the remaining part will be x XOR 4. The XOR value of the remaining part will be x XOR 4. So from this, like what we can do is that if we store the XOR value at every index using some map, then we can just find something like MP of x XOR 4. So this will basically give me the count of the subarrays whose XOR value is 4. Because if I find this like MP of X XOR 4, so this basically will point me to this subarray, means this subarray. So this is a subarray that is equal to X XOR 4. This basically means that the remaining part will have a XOR value of 4, which is square number. So we can subtract that one. Let's say there are multiple subarrays whose XOR value is also 4. So we can have something like this part. So this part up to this is also 4. Then again we can say that this part, this will have also have XOR as X XOR 4. So for the first time it was this part, and the next time this was this part. So at that time MP of X XOR 4 will be 2. So this will basically give me the count, like how many subarrays are there whose XOR value is 4. We can find it using MP of X XOR 4. Similarly, we can find for other square numbers, like we can find like how many subarrays are there who have the XOR value is 9. We can find that using MP of X XOR 9 and so on. So at every index, we'll check for all the square numbers. Now, up to how much will we check? Like up to which square number will we check? This is the question. Now, the question also states one interesting thing, which you should know. Like, the value of AI, this doesn't exceed n. The maximum value for AI, that is the maximum value for the array, can be n only. So we'll use this spec. So let's say the current value of n is 22. Now, in that case, if you take XOR of all the numbers, means the numbers AI can be anything between 1 and 22. Now, if you take the XOR value of any number in between, what is the maximum value that you can achieve? Think a bit. I guess it will be 31, right? Because if you take the binary representation of 22, so this is basically 2, 11, then 0, then 2, 1, 5, then 2, 2, 1, then 2, 1, 0. So the binary representation is 1, 0, 1, 1, 0. So this is the binary representation. Now, even you take XOR of any number in between them, the maximum value that can happen here is something like 11111. Means there are 5 bits, so the maximum XOR value can also have 5 bits only. You don't exceed that, and this value is equal to 31. So whenever we are at certain some n, we'll try to find out the number which is like which have all the bits set, something like this. So similarly, for when n equal to 2 into 10 to the power 5, you'll find that like the highest number that is the number that we have to check is something like let me just calculate that using the calculator. So that will be like 262,144. So this is the highest number, means that we have to check, or like or not exactly this, this will be like 3. So this is the number till which we have to check. So the if we take the square root of this, so basically we have to check around 500 up to, means up to a number like 512, the square of 512. Basically to check up to 512, or let's take one extra, let's say 513. So we have to check for squares till 513, means 513 square, then that will give the upper limit. So at every position, we'll check for all the numbers. So like we'll check for 1, we'll check for 4, we'll check for 9. That is, we'll check for 1 square, we'll check for 2 square, we'll check for 3 square, we'll check for 4 square, we'll check for 5 square, and till we'll check for 512 or 513 square. You can check for anything up to that. So that gives the upper limit. Now that might sound a little bit confusing. So I'll just use this example to try run. So initially, till this point, the XOR value is 0. So we can say that like here I'm mentioning the map MP of 0, this is equal to 1, because there is an empty subarray whose XOR value is 0. Now whenever we are at 4, so first of all we'll check like for 0. Why to check with 0? Because the question also stated that we can consider that 0 as odd number of divisors. So we'll check with MP of 4 XOR 0. So 4 XOR 0 is equal to 4. So we see that no, MP of 4 doesn't exist here. So that is of course equal to 0. Then we'll check for MP of 4 XOR 1. 4 XOR 1 is 3. Or sorry, 4 XOR 1 is 5. So MP of 3 that again doesn't exist. So this is again 0. Then we'll check for MP of 4 XOR 4. So MP of 4 XOR 4 is 0. MP of 0. So MP of 0 is equal to 1. So at this point we'll subtract 1 from the result. Initially our result is initially our result will be n into n plus 1 by 2. This is the total number of strawberries, and from that we are subtracting the invalid ones. So now we got that MP of 0, we'll subtract MP of 0, that is 1 from here. So what does that mean? Basically, you can see that like if you consider this strawberry, the exact value of this is 4. So we are whenever we are checking with 4 XOR 4, so we are getting a strawberry which is invalid. So MP of 4 XOR 4 is 0. So that is basically this part. So as said here, like whenever you're doing something like this, so you'll find the previous part which will give us the result, something like that. Now, do we need to check for any further thing now? For example, 9 or 16? I guess not, because till now the maximum value of XOR could have been 4. So checking with a bigger number doesn't make any sense. So we can just stop here. Or we can still check up to like up to the upper limit, which will be like which will find using this method. Like we'll find the highest number that will be having all the bits set for n. We can check up to that part. So similarly, we'll come at 2. Now also here MP of 4 is 1. So we'll write here MP of 4 is 1. So whenever we are coming at 2, first of all we'll check with 0. So 2 XOR 0 is sorry the here the XOR value is what? The XOR value will be 4 to 6. So the XOR value will be 6. Here XOR is 6 up to this point, up to this point. So first of all, we'll check with 6, then 6 XOR 0. So 6 XOR 0 is 6. So MP of 6 doesn't exist, so we'll only not subtract anything. Then 6 XOR 1. 6 XOR 1 is 7. That also doesn't exist, so we won't subtract anything. Then 6 XOR 4. 6 XOR 4 is 2. So 2 doesn't exist till now, so we won't subtract anything. Then we can check for 6 XOR 9. So 6 XOR 9 is what? 9 is 1001 and 66110. So this basically gives 1111. So this also doesn't exist, so we won't subtract anything. So that basically means that any subarray that ends at this point isn't invalid. All the subarrays ending at this point is valid. So we are not subtracting anything. Then we'll go for the next index, this one. So if you're at this point, so the XOR value will be 7. So here, first of all, we'll check 7 XOR 0. Okay, here I also have to have MP of 6. This is equal to 1 because we got the frequency as 1. So MP of now MP of 7 XOR 0. So that is MP of 7. So that is again that doesn't exist. Then 7 XOR 1. That is 6. Now 6 exists. So we have to subtract 1 from our result. Now what does that mean? That means that there is a subarray whose XOR value is 1. So basically, this is the subarray whose XOR value is 1. This remaining part, this is XOR value is 6. So we're subtracting this part. So whenever we're checking for MP of 6, so this gives me 1. So that means like this part, this is XOR is 6 and the remaining part has XOR is 1, which is a square number. So we're subtracting that part, subtracting that from our result. Then we'll check for MP of 7 XOR 4. So 7 XOR 4 will give us 3. So again, it doesn't exist. And then MP of 7 XOR 9. So that will be again something invalid, I guess. Yeah, something means bigger than our required thing, means that doesn't exist. Then we'll go for the next one, and before that we'll add mp of 7 to our list. Mp of 7 is equal to 1. Then we are at 5. So now what is the excel value here? 101. So the excel value will be 2. The excel value will be here 2. So here, like what you can do is, like, first of all, it's again start at 0. So 2 x 0 is 2. Does it exist? No, that doesn't exist in our map. 2 x 0 1, that is equal to 1. That also doesn't. So that is equal to 3. That also doesn't exist in the map. 2 x 4, that is equal to 6. So that exists. So we'll subtract again 1 from our result. Means whatever is the value, that will subtract. What is the value of the map, that will subtract. So what does that means? Uh, so what we're finding, 2 x 4. So that basically means that we're finding subarrays whose XOR value is 4, which is a square number. So you can see that, like, this is the subarray whose XOR value is 4, and the remaining part, this has XOR value as what? 2 XOR 4, that is 6. So this part is 6, the XOR value is 6. So basically we're getting this one. So we're subtracting this subarray. So the next one will be, we have got checked till 4. Then we can check for 9, 2 x 9, which is again like which will again which don't exist on the map, so we can exclude that. And similarly you can check for 3 also. So this is basically the whole method through which you can do this. So I hope the approach was clear. Now I'll just go to the code to check how we have done that. So this is the code. First of all, we have found all the square numbers, because, like, finding the square numbers every time is like doesn't make any sense. So we have found all the square numbers at the very beginning, like we have pre-computed all of them, so as to, like, just optimize the method for them. Then we have taken the inputs. Then we are finding the upper limit, till which number we have to check for the squares. So you can find it using any method. Like I use this method, like while limit is less than equal to n, then limit is multiplied by 2 every time. And we are using a vector instead of map. Where aren't we using a map? Because in the contest I've also used map initially, but that was giving TLE every time. We know that, like, every operation in map takes log n time. So that was like giving TLE, whereas any operation in vector takes big of one time. That is constant time operation. So since limit is a small number, basically, like this is also in the range of n, we can just take a vector for that instead of map. So we have first incremented mp of 0. So here we have incremented mp of 0. So, like, because initially we are considering the empty subarray which will have the example as 0. We are taking limit minus minus because limit was a power of 2, and we have to take one number lesser than that. Just like here you can see, while I was calculating this, I have subtracted 1 from it. Like the power of 2 was 262,144, and I have subtracted 1 from it. Then we'll go to every index. We'll add, like, either you can initialize result to n into n plus 1 by 2, or you can just add all these to result. This is zero. You can like calculate the whole number in any way. Then we're finding the current XOR value, that is XOR, and then we are checking for all the square numbers till our limit. Like, we don't need to check beyond the limit because that is useless. That won't give any result to us. So we are checking for all of them, and we're just subtracting that from our result. And at the end, we are again adding the current Excel value to the map. And at last, we are printing the result. So that basically summarizes the whole thing. If you got any doubts, you can ask in the comment section. So that is all for this thing.